Good afternoon, and welcome to Graph Data Modeling Tips and Tricks. My name is Max DeMarzi. I'm a Neo4j field engineer, and you can find out more about me and about Neo4j at maxdemarzi.com. I've also pasted a link to the chat for those of you following along, where you can see about 160 blog posts on different things you can do with Neo4j. You can also find me on Twitter at Max DeMarzi, and most of the things I do are open source and available for you on GitHub, so go check that out as well. So the agenda for today is we're going to talk about the property graph data model just a little bit to level set and make sure everyone is in a good spot. Then we're going to see the most important slide about Neo4j you will ever see. And if you want to stop paying attention to me after this slide, that's perfectly fine. It's all you need to know about understanding how Neo4j works. We'll go over the basics of modeling, and then we'll do some modelings for acting, for flights, for Twitter, for forums, for chains, and then we'll take questions and random things you have in mind. All right, so the property graph data model is a very simple data model. There's not a lot to it. There's no tables, there's no columns, there's no views. All we have is nodes, and these nodes can have labels on them. You can have more than one if you like, but try to just keep them to one. And the nodes can have properties. These are key value pairs that can be just about anything you want except nested properties. And then you have relationships, and they relate the nodes to each other by type and direction. So every relationship has to have a type and has to have a direction. And the relationships can also have properties. Oh, Chad, are you having audio issues? Hopefully everyone else can hear me. Looks like it is. Okay, good. So let's continue on. That's what you get. No views, no columns, nothing else to help you out. But with this small set of components, you can build everything else. So let's kind of go backwards a little bit and talk about what you might already know, and that's SQL. Right? If you want to join customers to addresses, the way you typically do that is you have a foreign key pointing from one table to the other. And if it's a one-to-one relationship, it's really simple. Say I have a customer, I have a foreign key of address, and it points to the address table, and everybody's happy. But the reality is people move, they change addresses, so they have multiple addresses. So then you need a one-to-many relationship. So then you put the customer key on the other side and point from the addresses to the customers. And then you realize, wait, hold on a second here. I have multiple customers at the same address, so that's not going to work for me either. So I need a join table, and then you have a many-to-many relationship. And what ends up happening is you end up having all of these many-to-many relationships everywhere, and it makes a mess of your model. Now, when you want to join these things together, you have to perform some kind of SQL join, a left join, a right join, an inner join. Some kind of join needs to occur in order to connect these things together. And the problem is they're executed every single time you create that relationship. And to execute a join, what it really means is you're searching for a key. You're saying, hey, I'm looking for this foreign key in a different table somewhere. And if you've done your database correctly, you have indexes in all your foreign keys. So typically you have a skip list or a B tree index, which is a wonderful data structure. It's a log n data structure, which means as your data grows by 10, you only go up one step. But as your data gets big and you end up with 1 million, 10 million, 100 million records, things start to slow down more and more and more. And with this slowdown, you get this terrible performance, and people look for alternatives. So we say relational databases can't handle relationships because of these reasons. The wrong model, they have this degraded performance, the wrong language, and they're not very flexible. To combat this problem, a bunch of folks got together under the moniker of NoSQL, but they can't handle relationships either. Most of the time, they don't even have joins very well. Like key value stores, they just have a key and a value. There's no joins at all. The column stores, they say, give me all your queries. I'm going to pre-join everything for you and sell you 1,000 servers because I have to duplicate your data again and again. The document databases take everything they know about a one object and squish it all together into a Baba JSON. They don't have real relationships either. It's only the graphs that actually have real relationships. So we have the same data as you would in a relational database, but we just have a slightly different layout. No more keys to worry about, no more joins to worry about. So let's talk about how this works. So underneath the covers, what we have is this weird double linked list relationship layout where everything is kind of tied together. It can get pretty ugly though. That's not really the thing you want to keep in mind. Instead, what you want to keep in mind is how Neo4j is able to store the data all the way down to disk. So we're not a graph library on top of a different database. We control everything down to the bottom. And if you know the internals of Neo4j, it can help you with your modeling, which is kind of strange. but I'll explain why in a minute. So this is the most important slide about Neo4j you will ever see, and I tell people this over and over again. If you understand this slide, you understand graph databases, and you understand the power they have and why they're different. So let's go over that, and hopefully you give me your full attention here. So this is what we put in the page cache. This is how Neo4j stores data on disk and in memory. And it's a slight abstraction of the picture, but you'll get the gist. We basically have two arrays, one giant array of nodes, one giant array of relationships. The nodes have what types of relationships are connected to it directly, and each type has two lists, one of incoming and one of outgoing edges. So let's say we have a social network. Node 1 is a person, and then type 1 could be the things they like. Type 2 could be their friends, and so on. So let's say we want to find these people. This person's 150 friends. We know they have that many. So we go to node 1 in the array, and we say, okay, go to type 1. Is this the relationship we care about? No. So we skip all of those. Instead, we go to type 2 and say, oh, hey, here we go. This is a friends relationship type. This is the one I care about. So we have two lists, incoming and outgoing. We're going to go into these lists, and we're going to see this R1, R2, and so on. All of these are just numbers. They're just pointers to the relationship array. So we can say, okay, R1 happens to be relationship 5. So we jump to the relationship 5 and say, okay, we came from node 1. That was our start node. What is the end node of this relationship? And it's node 55, whatever it is. Then we jump to node 55. We get some username property from that node, and we kind of continue on from there. We do this until we get to 150 jumps, going from the node to the relationship back to the node, and then we're done. And the beauty of this is that it doesn't matter how big your graph is, whether you have a million people in your graph or a billion people in your graph. Those 150 friends, the query to find them is always going to take about the same amount of time. And that's really the power of Neo4j, right? And I'll go over this a couple more times in this presentation to kind of just hammer it home. Now, one thing to keep in mind is properties on nodes and relationships. They're stored as single chains, and they can be of any order, of any size, of any type. So you can have two nodes that are the same label, so they're both users, with different properties. One person can have an age property that's the number 34. Another person can have the age property that's the string 45. And they could be in different places on that list. So it's very dynamic in nature, which is really nice. But it can lead to problems when doing some kind of queries, and we'll get into that a little bit more. By spinning through this data structure in memory, we can do about 2 to 4 million traversals per second per core. That's going from a node to a relationship back to another node. Hopefully you got the gist of that. So the secret to Neo4j is suites. No, not really. It's not the suites that built this thing. The secret is partitions. So each node's relationships are partitioned by type and direction. And this is really important because when you think about the databases you may have worked with in the past, you have these tables that get bigger and bigger and bigger, and these joint tables that get bigger and bigger and bigger. But what if they didn't have to, right? What if you could partition every joint table by the primary key of those joint tables? And it was done for you automatically for free. You didn't even have to think about it. It was done for you. So that when you run your query, you will only look at a very small subset of data, and therefore your queries will be very fast. That's what Neo4j gives you. By partitioning data and splitting it up into smaller pieces, you don't have to care about how big the overall graph is. You just have to care about how much of the graph you explore in order to get the answer you're looking for. Partitions is the way to think about it. So, hello slide, continue. Uh-oh, there we go. Okay, what does this mean though? So for some queries, and you have to remember it's not for everything, we're up to 1,000 times faster than other databases. For some other queries, we're actually 1,000 times slower than other databases because there is no magic bullet, right? There's no magic in computer science. There's only two things: data structures and algorithms. And with Neo4j, we have a pretty good data structure to how we model data, but it's not the answer to everything. So what are we talking about? Well, some queries, like for example, what is the average height of all the Hollywood actors? Well, how do we find this in Neo4j? Well, node 1 could be an actor, node 2 could be a play, node 3 could be a movie, node 4 could be something else. So we have to jump around looking for the nodes that are actors. And then we have to find this height property, which could be the first property on the list, it could be the last property on the list, or somewhere in the middle. And we're not guaranteed that the property is always going to be the same type. Sometimes it could be an integer, sometimes it could be a string, sometimes it could be a float or a double or who knows what. So those kind of queries are very painful. Why? Because they're single property, single model aggregation type queries. We're not awesome at those queries. We're much better at are things like 6 degrees, saying how are these actors connected to each other based on the movies or the plays or the commercials or whatever that they were in. Those kind of queries we're awesome at. Come on, next slide. There he goes. And the whole thing works as long as you can kind of reimagine your data as a graph, right? If you think about your data as a graph, you'll simplify how you think about it. You'll get hopefully better performance if you're doing graphy type of queries. We have Cypher, which is purpose-built for graphs, so you don't have to try to shoehorn SQL into trying to explain what you're trying to do. And it's flexible and consistent, which is very nice. It's what you want out of a database. I don't know why it's taking so long to switch from one slide to the next. Let's hopefully it'll get better. Come on, you can do this. Come on, slides. Oh my goodness, there we go. Okay, basics of modeling. Well, hopefully you guys are having a better experience. If you guys can still hear me in the chat, say hello. I don't know what's going on with this poor thing that it's struggling to change slides. All right, there we go. One of the first things we tell you, it's easy to model your graph. You just get a whiteboard, start drawing some stuff on it, and hopefully you understand what is going on. And it's a good idea to get your business people in the room because they're the ones that really know the model, the data you're working with. And you want to use their words, their terms, their vocabulary for building these things, not yours, not IT jargon. The tool we're going to use today is called Arrows. It was built by one of our developers here. You can use a whiteboard if you like, but what I like about Arrows is that it's simple, it's fast, and it doesn't run out of ink. There are much better tools out there, much fancier tools, I would say, but for something quick and dirty, it's the thing to use. So we'll paste a link somewhere later so you guys can get a chance to play with it. Now, I'm just hoping the slides will continue to work with me here because they seem to be moving very, very slow. Come on. So it looks like, okay, well, it looks like you guys are getting fast slides, I'm getting slow ones. All right, hopefully this will work out still. So a couple of things. One, nodes can have many relationships. That seems pretty stupid, but yeah, don't think that you're only stuck with one. Easy enough. Next thing. Wow. Next slide. Come on, you can do this. Well, I mean, at this pace, it's going to take forever to go through this. I'm not sure what to tell you. There we go. Okay, two nodes can be related by more than one relationship type, of course. You can have as many as you want. No, that's not true. The limit on the number of relationship types you have with Neo4j Community Edition is 64,000. You can get a little bit more with some of the special features in the enterprise version, but most people just try to stick with that 64,000 limit. which is quite a lot. And we'll actually take advantage of that in some of the models later on. I don't get why this thing is not moving the slides faster. It's driving me crazy. It's the worst software ever. What if we switch to the screen? Would that be any better? Come on. All right, let's share the screen and see if we can make this work instead. So I think we were over here. Let's hide the stupid layout. Here we go. So two nodes can be related by more than one relationship type. That's obvious enough. So think about when a person listens to a song multiple times. How do you model that in Neo4j, right? You can do one single listen relationships and keep track of each time they listened. You may want to say just a count, or maybe you want to have the time period or when they did it. But what if you want to say, well, they listened to the song for about 2 seconds and they moved on to something else? Then it might make sense to do multiple relationships. So think about how things are connected, sometimes more than just once. I mean, if you listen to popular music on the radio, you hear it over and over and again until it drives you absolutely bonkers. We also have the concept that relationships can have properties, right? Likes and loves is an example where how to quantify a relationship type between two people. You can also just put that into the property. Strength 3 and a strength 5 kind of mean the same thing. In Neo4j, though, the top version with likes and loves is going to be way better, way faster than the one at the bottom. Why? Because we don't have to look at that property on the relationship in order to traverse. You can just say, I don't want to see anything I like. I just want to see what I love. And it's going to skip all the likes that I may have on there. And those kind of things will help your performance. So you have to think about when you're doing modeling, you can avoid those relationship properties, then things will be better for you. But don't get too crazy with it. Don't overcomplicate it. For example, you have a person who lives at an address and works at an address. Okay, that's fine. We could also just have a has address relationship type with a type in their home and type work. Which of the two is better? Well, the one on the bottom is better. Why? I just told you that relationship types should be what I use. Well, how many homes does a person have, right? Typically, you only have a couple of addresses. Unless you happen to be a real estate investor, you only have one home address and probably only work at one place. So just keep it simple and stick with the bottom one instead. So don't think only about the types as a way to differentiate the relationships and qualify them. But also, if you don't have too many of them, just keep it simple to make your models a little bit better. And then we have the idea of symmetric relationships, where a person is a parent of and a child of another person. Obviously, don't pick the one on top, because in Neo4j, you can traverse from either side. So it doesn't really make a difference, other than you're wasting CPU and wasting memory by taking space away from everything else by adding this secondary relationship that you don't really need. Although for some cases, you do need this. For example, in a Twitter example, where you can follow someone, but they don't actually have to follow you back. And that's a fair reason for why that might be something that you want. So let's talk about audio acting. I just want to check, make sure that everything's still good. I think so. The first slide we tell you at Neo4j is draw out your whiteboard, get it on there, and see what happens. And if you were thinking about modeling acting, you can model it this way. You have these people who acted in movies, and you have the roles as a property of those acted in relationships. And this works for some queries. But then if you ask the question, who played James Bond, then this is a terrible model for that, because you don't really have indexes on relationship properties. So you would probably be better off having a node that represents the character of James Bond, and then figure out where the person acted, who acted, and what movies they were in. So this model is dependent on the questions you're asking, and that's something you're going to see again and again and again. There is no right way to model data in Neo4j. There's plenty of wrong ways, but there's no right way. The right way for you depends on the use case you're trying to build and the questions you're going to be asking of your data. Now let's look at modeling flights. And you may have seen this example on the web before, but this is how crazy you can get with modeling. The question we want to ask is, how do I get from one airport to another? How do I get from one place to another? And you can model it simply this way with 2 airport nodes, the name and a code, and then all these flying to relationships. And let's imagine we're keeping a year's worth of data. So if you wanted to make this search happen, I find the airport that I care about, and then traverse all of these flying to relationships for a year to get to the airport on the other side that I want to get to, and filter by the date. That seems like a very painful process. What else can we do? Well, we can model it as a flight. That might make sense later on because I want to book a flight. I want to see does this flight have room? Who's flying this flight? What kind of flight is it? Is it usually late? Those kind of questions. But it doesn't actually help with getting to an airport faster. So we can rethink our model and say, you know what? People don't just fly randomly from one airport to the next. They fly on particular days. So we can extract the concept of an airport day out of this model and say on this airport, let's say Chicago O'Hare, on this particular day, they have 1,000 flights that are going to some other airport. So instead of having to look at 365,000 potential flights for a whole year with an airport, I'm just looking at 1,000 flights. That makes life a little bit easier. Now keep an eye on this has day relationship type. We can actually say, hey, it's a type of a date. So instead of having to traverse the has day and checking the date, we can just use that relationship type as a date to get there directly, which is kind of nice. But why even do that at all? What we can do is get rid of the airport and just have an airport day that has a code and a date, and just connect that to the flight and the flight to the other airport day. That slims down our model, and it's pretty nice. But this is graphs. You are allowed to get way more creative than that. So what if you realize, well, on this airport day from Chicago here, we have 1,000 flights, but they don't go to 1,000 different places. They only have maybe a couple hundred destinations at most. So we can extract the destination of where these airports are going and then connect them to those flights. So for example, if I'm going to JFK, I can have a JFK node and then have flights that only go into JFK. So I can reduce the search space and I can look at less data to get the answer that I want. And then you can get even fancier. You can say, you know what, forget that idea. I'm going to take away the destination node. Instead, I'm going to make it a relationship type. So the airport day has a relationship type of where the flight is going ahead of where the flight is before he actually even gets there. So we can just say, okay, go to the airport day for Chicago on September 10th and say, find me the flights that are going to this airport code and just give me those flights. I can ignore everything else. I can ignore the whole year worth. I can ignore all the other destinations. It makes my queries very fast because I'm using the data modeling capabilities of the graph to reduce my search space to make my queries very, very fast. And that's the thing you have to remember, right? You are allowed to do whatever you want. There is no third normal form in graph database. You are allowed to bend the data to your will and do whatever you would like. Let's talk about another example. Let's talk about modeling Twitter. So Twitter is really simple. It's just a news feed. So people post things that you follow, and then you see what they're up to. By the way, we have a Graph Connect 2020 in New York City, April 20 to 22nd. I think we're still selling early bird tickets. So if you're interested in that, go take a look. Now, the way other databases would model this data is that they would multiply your data out. Every time you posted something, they would look at all your followers and add something to their feed. And the problem with that is that if you have 2,000 followers, not a big deal, but if you have 10 million followers or 100 million followers, you're actually multiplying your data quite a bit. And that's not how we do it in Neo4j. In Neo4j, we do something different. We say, you know what? I follow a bunch of people, great, and they post something. So I can just go from the user to everyone I follow and see if they posted something. I can sort on the time of the posted so I can get the nice ordered list that the Twitter gives you. But this is actually a bad model. You don't want this model. Why? Because it will work great on day one, but after 5 years, you have to look at everyone you follow, look at 5 years worth of their posts, and then sort them. So the query is going to get slower and slower every single time, and that's not the Neo4j way. A better way to do it is to model it this way, where you see who you're following, and then they post something on a particular date, and you just use Neo4j's ability to partition by relationship type to find those posts on this particular day, and then your query stays pretty much flat always. So
hi Max, are you? Sorry, I don't know if you can hear me. The slides aren't updating. So I think it says, I'm just looking at my one, so I just refreshed the session. It's slide 28 of 70.
All right, I must have dropped out. Oh, that's so annoying.
Yeah, so to everybody on the session, we will be sharing the slides as well. So we'll see what we can do to make it up to you. Sorry about that.
Lovely. All right, well, we'll try this. Can you guys see the screen now with modeling a Twitter feed? Can you see this now? Anybody there? Yep.
Hi, Max. Right. Yes, we can.
All right, let's continue on. So why did we do this? Why did we do the relationship type on date? Because we are using this filter that I showed you earlier to delimit the relationships that we care about, and that we can ignore everything else that happened before that or even afterwards and just get the 1 day's worth of followers relationships for that day. And that's what's neat about Neo4j. And I show you a real example of this. This is from Adobe. So they've built this activity feed, and they used to run this on Mongo, the 125 servers and 20 terabytes of data. Then they flipped over to Cassandra with 50 servers, 50 terabytes data, and they realized they can actually run this on Neo4j with 3 little boxes. And since they don't have to do that data multiplication, their server's data size went down to just 33 gigabytes. And the trick is, if you can make the query scale, then you don't have to scale the databases. And that's why we don't make any money here at Neo4j, which is unfortunate. Otherwise, I'd be retired somewhere. But regardless, it's good for you. Even though scaling out is in fashion and everyone's about going distributed this and distributed that, when your model and your queries match, you don't have to scale out. You can be smarter about how you'll be able to do this, which is neat. Let's talk about something else, modeling forms. So this is the T-1000 Terminator from the movie Terminator 2. And you'll notice he has 3 hands. One to flood the helicopter and another one to shoot someone with, right? When you're modeling data and graphs, you don't have to stick with what's normal out there. You can get fluid, you can get creative, you can get it more interesting. And just think of that. You don't have to kind of draw out a crazy ERD diagram of how everything is going to be connected ahead of time. You can be fluid about it. So, for example, if you wanted to model any form that anyone will ever fill out, you can model it this way. You have these projects, they have forms. The forms have fields. The forms can have any number of fields. The projects can have any number of forms. And then these people have filled out these values, and the values can be of any type. They could be an integer, a string, comment, whatever you want. It doesn't really matter. But this is a simple way to model that. And you don't have to model every single question, every single field, every single form as a separate table. You can just model it with this 4 simple nodes, and everything is there for you. Everything can be fluid, which is pretty crazy and something you really can't do with other database systems. Wait a minute, though. What if they fill out a lot of these forms? And what if you want to see if they fill out the same form twice, or these things are linked together, or what's going on? Are we missing some kind of concept? And we might be, right? We might be missing the concept of responses. So a person has a response, and that response is of a form. And those responses have fields, have values. A response node is what we call a hyper-edge node, which is really taking an instance in time to connect multiple things together that in a previous model didn't really need to be there. Here, didn't really exist, but it was kind of implied that there was a response. In this model, we're kind of making it explicit because we want to be able to do something more with that response, like link them together or connect them to something else, which is kind of neat. And then we have the concept of also modeling chains, which is hard to do in relational databases. I imagine you have these credit card holders who are making transactions at these merchants. And you can model the data this way, where a user makes a whole bunch of transactions, and that's fine. Everything is connected kind of in a single hop format. But a better way of doing it would be to model it in a chain so that you can see what the previous transactions are for any node. And the reason we want that is because we want to be able to go back and find these chains and see where the chains connect, see where the same merchant touched these accounts. We can kind of see where the fraud originated or where these credit card information got stolen along the way. When you put a whole bunch of chains together, things get interesting, and you can see where multiple people stood, or multiple paths, where they diverged, where they combined. And that's what makes a graph, not just the single lines. But by combining things together, we can go back and say, hey, look, they all went to the same gas station. And this is probably where they got their credit card information stolen that caused these fraud things to happen later on, which is kind of neat. All right. It's kind of a wacky presentation because of all the technical issues we had. And I'll try to go back through and go through the QAs. But there's some Hunger Game questions that were out there. What is the tool Max uses for modeling? There's a bunch of them out there, but there's one that I love because it's quick and dirty. Second question is, how many relationship types can I use in Neo4j? These are your three options. And then the fourth one is, the third one rather, is what is the secret to Neo4j? And while you're thinking about filling those out, I'll take a look at some of these QA questions. Jessica asks, I love arrows, but are there better tools out there? Yes, there's a ton. Just a matter of what you like. I mean, you can use your traditional ERD diagram tools to build this stuff. Self-referentials, definitely a missing feature that's not in arrows. What I usually do is just link to another node of the same type, and then you just put it one on top of the other. But usually self-referential loops are weird. I don't know why you would want that in your model. Other questions. If two people have a mutual relationship like siblings, how do you model that? The person has a sibling and the other one has a sibling. Well, it's like the nose relationship. If two people know each other, you don't really need to model the way back. Sibling is the same idea. If you are siblings of each other, it's implied that that relationship exists both ways. So in your scientific queries, you can ignore the direction of the relationship type. And that works. Pros and cons of multiple labels. Well, the indexes are tied to a label. So if you have primary keys or keys you're going to be searching for, you have to duplicate them every time if you have multiple labels on a node. So stick to one primary label. Use multiple labels when you want to add a Boolean or a flag or some kind of property that you want to look at, like someone's a suspect or you want to revisit that node for one reason or another. But it's not recommended because of an indexing issue. The 64,000 limit was on relationship types. And there's a way to do 16 million on the enterprise edition, but most folks just stick with that 64,000 limit. That's plenty, I think, in most cases. How efficient is Neo4j at parsing properties of relationship or large queries? Terrible. So we get our speed on the fact that we have this partitioning based on relationship types. So if we can not look at those properties, you're going to get orders of magnitude faster performance than if you have to open up the relationship, look at the property store, find the property you care about, convert that into whatever object it is, and then compare it to whatever value you're trying to filter on. So the alternative to that is use your types. Try to make that work for you as much as you can. Otherwise, you're going to be paying a price that you don't really need to. Let's see. What do I recommend for network infrastructure modeling? I mean, nothing specific. I think, like I said, I like arrows, but people are free to use whatever they want. What we found with customers that do network infrastructure is that they have typically 5 or 6 tools, all telling them different things. So what you want to do is actually model them kind of separately, but together, so that you can actually put the graphs that they tell you on top of each other and see where the graphs are the same and see where the graphs are different. And that's going to tell you that your tools are either lying to you, or they're misconfigured, or they're telling you different things. And you want to get the different graphs to to be as close to the same as possible over time. So that means going back to the source system and fixing them until eventually all your systems are saying the same thing. Another question. How do you decide which way the mutual relationship is modeled? Because when you query, you have to choose a direction, don't you? No, you don't. You don't have to choose a direction when you query. That's kind of the nice thing about Cypher. You can skip the arrow sign and say it's going to be on either direction. I don't care, one way or the other. Both will work nicely for me. The tool of choice for modeling is called arrows. I'll paste it here on the chat window. It's really simple. I mean, you can just use a marker if you like. But what I like about it is that I can build them fairly quickly. Usually what I do is while I'm having a phone call with someone, I will be building their models and their their queries all together, so that we have something that we can both look at and base it off of. There's a whole bunch more examples of this kind of modeling on the blog. A few of the really good ones that are out there are things like modeling events. It's a great blog post to look at. Look at the bill of materials blog post. Look at IVR blog posts. All kinds of things that are out there. Oh, doesn't arrows just save your model to the cache? Yes. So you need to do is you need to export it to a HTML and just save that export, which then you can go back and reuse, or you can export to an image. At least you have a picture of it. Is there recommended relation for properties that are lists of things, names and numbers? Well, lists are fine. You can do lists in Neo4j. You can do arrays of properties of the same type. So an array of strings, an array of doubles, an array of integers. Those are perfectly valid and allowed in Neo4j. What's not allowed is combinations of things. So you either have to convert everything into a string and use that as your default, or you have to create two properties with different types and just kind of assume that the third item on one list is the same, is combined with the third item on the second list. And that'd be one way to do it. I've been begging for nested properties for about 5 years, so we can actually have like objects stored in Neo4j. One day we'll have that, but not today, at least not with 4.0. Let's see, another quick question popped up. Do you have any better way than optional match to bring back a pattern, say person and address, plus another relationship plus node if it is there? So email. Well, you can do optional match. We also have the pattern comprehensions, which are kind of the same thing. Sometimes you just want to know if they even have a relationship. You don't necessarily need to know what the other node is. So you can use the size in Cypher to say where size of some relationship type is greater than 0 to see if the relationship exists. That's one way to do it. How would you model time-based versioning so you can go back in time and see how this graph was at point in time? That's very painful to do, right? There is a blog post out there that explains how to separate the graph structure from the graph state, and that's the correct academic way to model data. It was something that was written by Ian years ago. There is no pretty way to do it in Neo4j otherwise. Sometimes you don't really care though. Sometimes you're more concerned about just when things get added. So in that case, you might just have a property on the relationship type, or in the relationship rather, or on the node when it was last updated, or when it was added. So you can say, okay, these people became friends on a particular date. Maybe they stopped being friends on another particular date. You may have a start date and end date for the relationships. But as far as if you want to keep track of changes to the properties themselves, it's going to be quite painful. I think you'll have to have another node linked to that with a previous version type setup. Any other free modeling tools people use? I mean, the whiteboard and your brain are as free as you're going to get. You kind of have to just, like I said, reimagine your data as a graph, doodle it out on a piece of paper and pencil until something makes sense. And I'll stay here as long as you guys need me. Let's see, another question. Link to that blog post. Oh, the time versioning one. Ian. That's going to be hard to find. Ask me on user Slack, and I'll try to find it for you. We also have copies of it in the, or we talk about it rather in the Neo4j modeling class that we do. Does the same inefficiency apply to node properties? Yes. So reading a property is way slower than traversing through a relationship type, regardless of whether it's a node property or a relationship property. Obviously, you can't have a graph with no properties. That'd be kind of weird. What Slack? The Neo4j user Slack. If you're not on there, basically it's real-time access to the Neo4j folks, which is kind of neat. Let me paste that in there. Oh, and Neo4j is telling us that the next version, the next talk is on versioning, so that will help you with that idea there as well. There we go. Someone else wrote, draw IO is good for making quick diagrams. Yeah, I mean, arrow is simple, right? If you want quick, that's the alternative to a whiteboard. I can't draw for shit, so that's why I use arrows. But if I would draw, I would just draw markers. And thank you for the invite to the user Slack. And we also have a forum. So if you want a more, not real time, but get back to me within a few hours or in a few days type of questions, you can use the community.neo4j.com to get answers that way too. Yes. Yeah, I mean, one of the services we provide for free to people is to review your model. So if you have a question about your model, just get on a phone call with us and we'll happily talk about it and look at it and give you some pointers or ideas. Thank you very much for your time, guys. Take care.